Why should data-centric architecture and virtual conference development merge into a single lane? Because when it comes down to it, their road is the same. Unwind past assumptions and construct a methodology that mirrors the way the world works. In other words, make it real. Welcome to the Data-Centric Architecture Forum.
Well, good morning, good afternoon, good evening, wherever you're coming from. Welcome to our third annual Data-Centric Architecture Forum. This is our first ever fully virtual one, and I hope it's a good experience for you. One or two thoughts I had, and then I'm going to launch into my slides. But if you could block out your entire next 3 days on your calendar, I know what happens, but when people request meetings, tell them that you're at a conference, and if they still persist and they don't know what that means, tell them you paid to be there, and see if you can fend them off. See if you can be here for most of this, because it's going to be very interactive and I think very exciting. So with that, let's start the presentation. What I really wanted to talk about today was why data-centric is both inevitable and at the same time why it's still so elusive. We've been at this for a while, and it's harder than it first seems. And I am going to talk about those two themes, but since I'm kicking this off, I sort of owe it to everyone to at least say what data-centric is. So that's how I'm going to spend the first bit of this. I'm going to rush a little bit because I have more material. I started this presentation with the inevitable elusive theme and then added the data-centric back on. So I probably have too much material, but when you try and compare data-centric to, some new piece of software or a new language, many people just want to know what's the syntax. I can learn this. I'll know it in a few weeks. I can take it from here. And after we've studied it for a while, it isn't really what it is at all. It's more about a paradigm shift. And I know that's a term that's been overused, but I think it's pretty appropriate in this case. Things continue on as they do for long periods of time, as they have in enterprise IT for 4 decades now. But eventually they sow the seed of their own problems, and something new emerges. And that's kind of where I think we are here. The Thomas Kuhn, who wrote The Structure of Scientific Revolutions, had something similar to this that says up there at the 2 o'clock position, things are going along normal in science. After a while, things start to drift, and eventually what we're doing isn't working. By the time you get to the 6 o'clock position down there, and something new emerges, and the new paradigm eventually replaces the existing. So that's where we are now. I think Buckminster Fuller put it well. You don't make this kind of change by operating inside the existing paradigm, but build something else that makes that obsolete. I think it's exactly where we are now. So once upon a time, probably before many of your folks' time, the sun actually did revolve around the earth, did for a long time. You could just see it come up in the east and go down in the west. But somebody started noticing, this is the beginning of a paradigm change, that these wanderers, planets like Mars, would move through the constellations, not literally as you could see them, but as you can see on this, every week they'd be in a slightly different position. They figured out that's fine, but then if you really measured carefully, you'd notice it gets to a certain point, it backs up and goes the other direction for a while and then goes forward. And so people wondered, what could possibly explain that? And people came up with all kinds of pretty fantastic explanations. Well, it must be circling around an imaginary circle. And they kept drawing more and more elaborate versions of this, because the more they measured, the stranger it got. Here's a fairly interesting, elaborate one, until Copernicus finally figured out if we change the initial premise, maybe we don't have to have all this complexity. So instead of putting the Earth at the center, if we put the sun at the center and redo our calculations, you can sort of trace here's where Mars is going and why it looks like, based on the relative speeds of the two planets, that it's going forward and backward, doing that retrograde motion. So That's all sort of analogy and intro. What is happening with enterprise applications? When we talk about enterprise applications, we're mostly talking about traditional payroll, CRM, inventory control, ERP, all those, but hundreds and thousands of things that we use to run our businesses. Here's what they look like, at least in the abstract. And at this level, it looks so simple and it looks so nice. It looks, we've got a user interface in the front, we've got a bunch of business logic in the middle, and we've got a database and a server at the bottom. And this little picture has been around 30 or 40 years now, ever since there have been interactive user interfaces. And it creates this illusion that things can be plugged and played and it's all interchangeable and little components and everything's nice. But nothing could be further from the truth. Hypothetically, you see a database down there and you think to yourself, oh, I could just read that database. But if you've ever been in a corporate environment, you know that they're not going to allow you to do that because that model is incredibly complex and you would misinterpret it if you just read the raw data. Furthermore, you might say there's a database there, I could just insert data in it. They would be more horrified if you suggested that because they know that if you did that, you would violate all that business logic that's in the middle layer. So what they actually do in enterprise applications, they provide APIs for you, and that's your way in. The net result of all this, it looks like it's this simple modular, you can take pieces in and out and all that kind of stuff. But the truth is that's a fiction. These systems are very often millions of lines of code. They're monolithic. Any one change to anything, change to the database requires change to the code requires change to the user interface, vice versa. It's all interrelated. And the net result is your data is held hostage to these systems. So the Copernican revolution here is to say, let's move from where the application code is the center of the universe and data revolves around it. While that may sound okay, when you actually, the equivalent of measuring retrograde motion, if you actually start looking at what's really happening, application code isn't the center of the universe. Application code is one of thousands of centers of the universe. Every one of these has its own captive data model that it has defined and maintains and all that kind of stuff. And then we attempt to share data between them, as these arrows indicate. But really, you're not sharing data, you're sharing little pieces of code that share data. This is what systems integration is, this is what ETL is, this is what all those tools that help put a Band-Aid on this horrible situation. But what we want to suggest is the future is kind of beyond putting Band-Aids on this bad situation. Now, the other problem that's kind of hidden in these simple diagrams, these systems have hundreds, thousands, tens of thousands of tables in many cases, and each table obviously has dozens to hundreds of columns, amazing amount of complexity. And the code has to deal with all that complexity, and the humans that deal with the data have to deal with all this complexity. It's vastly beyond anything any human could manage. So what is keeping this situation, if it's as dire as it sounds, what keeps it locked in? And what's keeping it locked in is every time a business person has a problem, they decide to go solve that problem. And in the Kuhnian revolution here we're in normal science. We think we know how to solve these problems, so we're going to keep solving them the way we've always solved them. We form a committee to solve the problem. Very often the committee determines that the problem is really an information systems problem. So they put together another committee and they have a decision to make. And they feel like this decision is crucial. And the decision is either, should we build a new system, which is what people did for a long time? Should we buy a new system, an application package? Or these days, should we rent a solution? Should we get software as a service and just pick up something and start using it? But here's the reality, and here's where the paradigm shift is broken. It doesn't matter which of those three things, which of those three decisions you make, because each of them ends up in the same place, which is each of them ends up having you implement another completely arbitrary, complex data model that has nothing to do with the 500 or 600 other data models you've already implemented. This is where the modeling crisis becomes, because every time you solve a problem, you make your environment worse. So this is the tip of the iceberg. Most large enterprises have thousands of these. They're massively complex. We work with a data profiling company that went into a very large enterprise recently, and after profiling all of the data and all their databases, found that they had 200 million columns under management, not 200 million rows, 200 million different named concepts that software has to know about, people have to know about, somehow you have to manage. It's quite beyond broken. So the new paradigm, looks simple at this level, and it hardly looks that different. But we're going to talk about exactly what the differences are, and then eventually get to why this is inevitable and why it's elusive. I've got a kind of a run-on sentence here with about 5 adjectives, but I think they're all pretty important. We like to say that this is not a binary thing. This is not a piece of technology you buy. This is not something you can just do tomorrow. It's a process. It's a transformation, but you will be data-centric to the extent that the functionality you have, whether it's written in code at a very high level or model-driven or whatever it is loosely bound. So we don't have millions of lines of code, each of which refer to specific columns and fields and things like that, to a single, simple, extensible, federatable, shared model. That's it. I'm going to blow out what each of those things mean. So there's the adjectives, and they make the most sense when we kind of juxtapose them to what we've been doing for the last 4 decades. In the application-centric world, where every time you solve a problem, you build another application and create another database, you get one model per application. Therefore, if you have 1,000 applications, you have 1,000 models and 1,000 things to resolve. And the central idea of data-centric is one core model per enterprise. Maybe at some day we'll have one per industry or even one in total, but right now I think one per enterprise is already pretty ambitious. We're also promoting this idea that the model be simple. In the application-centric world, there's often thousands of concepts per model, and you have thousands of models. The whole thing is complex. Even individual pieces are complex. What we've discovered through a lot of experimentation is that it really is possible to get to where that central core just has a few hundred concepts, typically 400, 500, that kind of size. And the third part of this is that it's extensible, not that one model is going to solve every single business problem, but that when you want to make change, you can do it incrementally. In an application-centric world, any change that you want to make, everyone has to take. So you've got a database, an inventory database, you want to add a few extra fields, and you have to go talk to everybody and make sure everyone is okay with that. There's no real mechanism for saying, yeah, I like the system the way it is, but I would like to just extend it a little bit in my corner of the enterprise. With this data-centric approach, there is a shared core. Individual subdomains or departments or divisions can extend it without disrupting. I have a little example of that here coming up next, just to get an idea of what we're talking about here. So this was an enterprise ontology we did a long time ago, back before we were doing implementations even, but I like it because it's very concrete. The Washington State Department of Transportation, we built an enterprise ontology. It had a few hundred concepts. Here's 10 of the more ones you'd expect, all that, vehicles, et cetera. That's what the Department of Transportation deals with, including in the lower right-hand corner, my personal favorite, roadside features being anything you might be able to hit with a car that would damage the car. Everything from lamp posts to signs to big boulders to trees that are close to the roadway. And then someone discovers that there is a database somewhere of all the fire hydrants in the state of Washington. And obviously these are different field names, they're different concepts, but it's possible to create an ontology that's an extension of the core that covers this information. In this case, we said that the water flow, the gallons per minute, is actually kind of a magnitude. Adjusted lane miles is a way to find location, contacts. Fire departments are organizations, and of course, fire hydrants are roadside features. You can hit them and damage your car with them. They need to be close to the road. So that's what we mean by extensibility. It's not go create which is what they did in the traditional world. You create a whole new system to handle the fire hydrants. Here we say, no, fire hydrants have all the characteristics of a roadside feature, including knowing where it is, a lot of other things. We're just going to extend it a little bit and say our fire hydrants have these features. Federatable, in traditional systems, there's people almost never do multi-database queries. There are some virtualized databases now that make this at least partially possible, but for the most part, for most of recorded history, people have just said, I'm only going to query within my actual database within my one vendor. This whole data-centric thing is based on standards that right from the beginning were meant to be web scale, federate over many engines, different model, one shared model, but querying over many implementations. I'll give you click the thing. We'll see a quick example of that here. Going back to our little fire hydrant thing, imagine that we map the relational database using an open standard here to this extended ontology. We're going to run a query. Yep, there is. Imagine writing a query where you only knew the metadata up there in the green area. So in a typical system or a typical database, you have to know everything before you get started. You have to know all the metadata of that fire hydrant database before you can join tables and get anything done. But in this world, the little green things, RF's roadside feature, PowerPoint didn't have a lot of space here. Give me the roadside features between these two locations, and it will query this extended model, even though you don't know about it, and return a data set about things that at this level you didn't know. You didn't know that it is a fire hydrant. It's telling you it's a fire hydrant. You knew it was a roadside feature. You knew where it was. So that's the basic concept of federation. And then finally sharing. In the application-centric world, people are typically not concerned with sharing at all. I'm solving my specific problem. If I want to copy and paste some data from somewhere else, I will if it solves my problem, but that's the extent of it. Data-centric is all about sharing by design. How much time do you spend thinking about and sharing your model and your data? So here's getting back to our vision. We want people to start imagining there is a single simple model, and the use case is sort of like the apps on your app phone, but the apps on your app phone are not really very integrated to each other. There's a few of them that might be integrated to your calendar, one or two other things like that, but for the most part, they're not integrated to each other. In the enterprise, the ordering systems have to be integrated with the inventory systems, with the collection systems, all that kind of stuff. It has to be integrated, but it can be integrated even without tight coupling. So, that's where we're headed. The end of legacy systems, the end of data silos, the end of death marches, all that kind of stuff. Lots of little lightly bound bits of functionality sitting on top of a shared model. So now that was a very quick version of what it is. I want to talk a little bit about why we think it's inevitable and then why it's been elusive up to this point. So I kind of, by analogy again, want to talk about some things that are inevitable. I think there's a lot of evidence for inevitability, even though in the immediate moment, it doesn't seem like it. Right now, electric vehicles are 1% of the US market. People kind of ignore them for the most part, but they are completely inevitable, and let's look at why they are, and therefore, by analogy, why this is inevitable. So the first Tesla Roadster had the equivalent of 800 laptop batteries in it. They just went out and bought laptop batteries, strapped them all together. And yet, even with that kind of crude beginning, they had a vehicle that drove faster than a Ferrari, 0 to 60, 3 seconds, just snap your head back on. And even though electric vehicles have been around for decades, as soon as they started doing that, people started going, oh, yeah, there's something going on here. So they have a power advantage. They have a cost advantage. While the cost of batteries has been dropping 20% a year, that doesn't sound like all that much, but what that means is it drops in half every 3 years. And every time the major cost of something drops in half, pretty soon it gets pretty cheap and pretty affordable. So much so, nobody's noticing. This is an interesting curve. Sometime this last year was pretty much the crossover point as to where an electric vehicle is now cheaper to operate than a gas-powered vehicle. And yet our own inertia is we're still buying 99% gas-powered vehicles just because that's what we're used to. We can see this, we can know that it's inevitable and still not do anything about it. But we have some existence proofs, just like we do with Data-Centric. There are existence proofs out there, and we're going to see a lot of them this week. The existence proof for electric vehicles in Norway, where well over half of all the new vehicle registrations now are either pure electric, half are pure electric, another sixth or so are partial and hybrids and things like that. So that's kind of a sneak peek of the future. And then the final nail in the coffin, I think, for electric vehicles, and we're going to try and look for a parallel to this, is even GM, even the dinosaurs have said they're going to be out of this business in 14 years. Now, that may seem like forever from now, but if you're designing, if you're building a gas station, you might want to think about that. You got a 15-year payback period. It will change the economics a lot. So our equivalent to power, this is the linked open data cloud. There's a huge amount of human knowledge is already in this format. It's available. That entire pink space down there at the bottom there's the human genome, proteomics, all scientific stuff, amazingly connected. And each one of these bubbles is a very large data set, most of them hundreds of millions or billions of triples or facts, many different topical areas. There's an amazing amount of power there waiting to be consumed. This technology is far more flexible. This is, from the Google knowledge graph, but I think it gives you a sense that any one of these nodes can be a specific person, the concept of persons, places, and it's just a matter of adding another link to add additional information. And every kind of thing doesn't have to have, it's not like a table where every person has to have all the same columns. I mean, you can sort of see just by looking at this that different individuals, different places, different things can have different information attached to it. And it's really a matter of knowing what these links mean and keeping them down to an economical number so you can understand it. That actually the technology works even if you're profligate, but it works a lot better if you can keep it simple. And the economy of this, I mean, what is really the wind under the wings here is just how bad the existing economy has become. That people don't think twice about spending $100 million to implement a new system. And very often they're implementing a system because one of two reasons: either the technology underpinning the existing one has become obsolete, which is a horrible reason, but unfortunately it's true, or very often there's just a handful of extra features that you can't get in the existing system. Maybe it was a packaged system and they just don't have those features. And eventually people get frustrated enough and they say, well, I guess the answer is to replace it. And the replacement equation eventually comes down to where this will be hundreds of millions of dollars to replace. And in the data-centric world, when you've gotten to a mature environment, you look at those features and you just say, well, those are just sprints. Those are just we'll just add them because it's possible now in this architecture. Okay, so if it's inevitable, and a lot of people that are here already believe it's inevitable, but are frustrated as we are that it's inevitable, but at the same time elusive. It seems like just one more project and we'll be there, or this should be pretty easy. And why are we struggling with this? I want to talk a little bit about why is it elusive and what do we need to do to overcome that? Because it's in some ways elusive in the same way electric vehicles are. So going back to this analogy I use in one of my books, once upon a time in the beginning of the Industrial Revolution, the way you made stuff was you had a factory that had a giant steam boiler outside because it was, polluting and dangerous and all that kind of stuff, that pistons, and was driving this giant shaft that you can see here that came through the factory. And what you did was attach belts to these shafts, and the belts turned whatever piece of equipment that you're using to make whatever it is you made in that factory. And this was, humming along in the late 1800s. This is how almost every manufactured good was made. And then along came the invention of the electric motor. And people kind of instinctively knew that the electric motor was inevitable, like in the same way that we think data-centric's inevitable. And yet it really didn't take over manufacturing for at least 40 years when it was initially inevitable. And some of the early experiments, you could imagine building an electric motor to replace the steam boiler, but actually that wasn't the sweet spot for electric motors. The sweet spot was to have a motor at every workstation, and the sweet spot was use that to have flexibility. You could invent flexible manufacturing just by moving machines around, where in that factory you just saw, you can't move the machines around. I mean, that was a 40-year commitment. Once you built the building and put in the shaft and set everything up, that's just the way it was going to be. But when people could see, an electric jig or an electric drill or an electric saw or electric anything was more flexible, it gave you a lot more options, it was more economical. Why didn't people change? Why did it take 40 years? And it was partly because it took a combination of professions and expertise to actually implement a factory. Back in those days, you needed an architect who could design a building that had the kind of tensile and torque kind of strength to withstand the fact that there was going to be this vibrating shaft going 24 hours a day for 20 or 30 years. I mean, you really had to have some expertise to build a factory. The people who were building equipment had been getting very good at it and how to, build it to be driven by this belt. And once the thing was up there spinning, it was almost free to put another machine on because, the thing was already spinning. You just had to pick up on it. People that designed workflow were experts in how to line things up under the spinning shaft. And, that was what workflow was back in the day. And by the way, everyone else was doing this. If you were manufacturing something and all your competitors had a steam-powered factory, you were very likely to do that yourself. And what's interesting about this and this thought is there wasn't a collusion. This wasn't a conspiracy of all these people to keep things stuck in the past. In fact, I have a feeling that most of these people didn't even know each other. The architects and the equipment manufacturers maybe barely knew each other. They certainly weren't all that cozy. The architects knew what kind of equipment was going to go in there, but they didn't care that much. They were just going to build a building with a big spinning shaft. And I'm going to suggest that that's kind of where we are right now. There's like 4 disciplines that are mostly being run by different people that all have to change simultaneously. And they kind of don't know. I mean, they know who each other is, but the existing folks are not colluding. They're all just doing their jobs. They're doing their project management job, their architecture. They're doing all these. And if only one of them tries to change, the whole system won't change. I'm just going to go through each of these a little bit at a time, just get a sense for it. Project management has evolved to, I was on a raft trip a little while ago. The last day of the trip, I found out one of the other guys there worked for a medium-sized systems integration company, and they were bidding on an $800 million CRM system for a utility company. And it doesn't occur to anyone that a utility company probably doesn't need to spend $800 million on customer relations, but maybe they do, who knows. But that's kind of the state of the art. This multi-year, huge list of requirements, complexity, RFPs, death marches, all that stuff. If you buy into that, and especially if you budget that way, it's kind of inconceivable, because I've tried this a few times. I know a lot about child support enforcement systems because we've designed a couple. And if you tell somebody who's embarking on a $200 million project that, gee, maybe you could do this incrementally in some several $100,000 projects, they think you're crazy. They have no idea. But anyway, that's one of the things that needs to change. Project management, not only agile, which is reasonably accepted now, but also adaptive and loosely coupled, some things that would make it be both agile and be able to fit into a longer term plan. The next little bit is modeling. So right now, people are used to, the idea that you have to have the model complete and exhaustive and all ready to go, because if you change the model, it's going to be very expensive. And that's literally true in the traditional world. So people have gotten used to that idea that, spend a year building an incredibly complex model because, a year from now, if you want to change it, all that code has to change, all that kind of stuff. So where we're going to go is what we're talking about here, a semantic, simple, flexible, federatable, et cetera, standards-based model. I think one of the reasons we like to promote the idea of standards-based is because we want these models to last a long, long time. I mean, they should last as long as the previous generation of systems has lasted. So, not everyone that you encounter is ready to change the way they model. In fact, if you hear the term enterprise data model, it usually means this gigantic, complex, multi-year, multi-thousand entity kind of exercise. So this idea of coding, we've got, there are millions of application developers now, and they're all writing code. They all like to get requirements and do their test-driven development and all that kind of stuff. The idea that business functionality is in applications is pretty hardwired right now, and almost everything an enterprise application does is done in application code, which is going to be a huge change. But we need to get there. That in this world of the future, as we're going to talk about this week, a lot of the functionality is going to be driven by the model, which means the functionality is in data. So it's data-centric as well. And then finally, the theme of this conference is architectures. Right now, every company has a quote, an architecture, but actually, if you really look, every application has an architecture, because if the architecture is database and messaging layer and libraries and interchange, all that stuff stacked up together, and then eventually to whatever you choose to use for your user interface, I mean, that's an architecture. That's what people call full stack and all that kind of stuff. And really, we need to go to this data-centric architecture. we have to change all these things simultaneously. And probably one of the hardest things is we know that we need a slightly different architecture. And for the most part, although it's beginning to change now, and I'm looking forward to a lot of things I'm going to see this week, that doesn't exist. We're at the early stage of this kind of revolution where, if you look at diffusion of innovation, very often right at this stage is where implementers or customers have to assemble the solutions themselves. So that kind of introduces this conference. A lot of what we're doing here is on that little rose petal or whatever you want to call it, is what kind of architecture are we going to have to support this world? Because when the application code goes away, most of what the application code used to do has to go on the architecture. So huge part of this is that little pedal there. It's also affecting the coding down there. And I think we're going to see some pretty interesting stuff this week. What Gartner calls low code, no code, or we're starting to call little code or model driven, is this idea, just go stare at the repetitive parts of your enterprise application and you'll see, rather than writing by hand 500 form driven screens, I could write one and just say parametrically what's different between them all. Now, the implementation is going to have to deal with project management and budgeting and modeling and all that kind of stuff, but that's not this conference. So if you haven't already, I wanted to put a plug in for the Data-Centric Manifesto. We kicked this off many years ago. There's been about 1,000 people have signed this. There's some evidence there, and people write comments that are very thoughtful and thought provoking. I read them a lot to get inspired. There's a lot of people out there that know this is the future, and they know this is where we need to be going. There's strength in numbers and all that kind of stuff. And obviously, the folks who have come to this conference have kind of come to the same conclusion. But if you haven't already, go have a look. It's like the Agile Manifesto was in its time, that a lot of people coming together and saying, yeah, we're kind of declaring this into existence. So there's my conclusion. Several people have heard this before, but I think it's absolutely true. I think what we're talking about here is the future, but it's already here. I mean, we're going to see almost everything that's necessary to make this work. Being not evenly distributed is not every company. In fact, most companies have not picked this up at all. Some are on the early stages of this journey, and some are yet to begin. But that's what it is. That's inevitable. I caught up a lot of the time I thought I was going to be behind. So with that, looking forward to it. See you in 7 minutes.